It's time for another math easy solution here to discuss, well, another problems plus example, this second one of the series. Basically just interesting and tough examples that my calculus book gives. So this one we'll go over it. Basically express the hypotenuse h of a right angle triangle with area 25 meters squared as a function of its perimeter here. So basically here's this triangle. Here's basically write this h in terms of the perimeter, which is perimeter is equal to, well, just the all length of all the sides on the outside, a plus b plus h. Yeah, thus we're supposed to write basically h of p. So it's a function of p only and without these a and b in there. So basically before we get to solving, let's just write down what we know. Well, the unknown is h, that's what we're asked to find, and the given is perimeter, just for any given perimeter. And then the area of that triangle is just 25 meters squared here. So what we could do is write down the equations that relates these quantities together. So we know from, well, actually the area is just the area of a triangle, and the triangle is going to be base times height divided by 2. So that's 1/2 times it by base, which is a, and height is b. See video link for proof of this. So we have this 2 right here, this function here, and then we know that by Pythagoras we have h squared, or the hypotenuse, equals to a squared plus b squared. You could also see the video link below for the proof of this. And then the last one, we have the perimeter, just a plus b plus c here. Yeah, so basically from these we get 3 equations and 3 unknowns, a, b, and h. So thus we can actually just solve for these. But the thing is, if we want to solve h in terms of p, this is actually pretty difficult from these equations. It's not a straightforward system of equations, so it's a bit harder to do it because it's got square roots, and I mean it's got squares, and these multiply by each other. But so the way to solve this is you have to look at stuff that is familiar. Yeah, so I just wrote that down. It's hard to solve directly, and so we should look for something familiar to simplify this. And to do that, look at the right side of all these equations. This one's a 1/2 ab is a squared plus b squared is ab plus c. This one's an h. Yeah, that's an h. I just got confused with the c right there. Yeah, so it's h. So basically, so now to look at it familiar, just look at this, and now if you consider multiplying like something like this out, if you FOIL out a function like this, a plus b squared, can you see how it is kind of familiar between these two right here? So we're gonna get this one. You could write it in 2 ways from above. You could just FOIL this out. This will just be a squared plus, this is going to be 2ab plus plus b squared here. So as you can see, there's an ab, and there's a squared plus b squared here. So you could also, we'll just simplify this further. We're going to be a squared plus b squared. Yeah, so if we just move it around, we get this, and then this one here, this one's just equal to h squared. So now this is equal to h squared plus, and now this one's 2ab. So if we multiply this by 4 on both sides, or 4a is equal to, well, 2ab. So 2ab is equal to 4a, and a is 25, so we're just going to get 4 times 25 here. And so we have this one's 100. We'll just write that down, h squared plus 100. But you could also write this in another way as well. If you look at the last equation, this one is p is a plus b plus h. So what we could do is just p minus h, because we know that, well, yeah, p minus h is just going to equal to a plus b plus h minus h equals to a plus b. So then if we square this one out, so a plus b squared is equal to, the square's outside there, so p minus h squared, and then if we FOIL this out, we're just going to get p squared minus 2ph plus h squared. So we got now 2 equations for this a plus b squared, and then we could just put them together here. So we could just set them to equal to each other. Thus we get p squared, p squared minus 2ph plus h squared is equal to h squared plus 100. So we just put these equal to each other because they are, because of this relation right here. So now we could just simplify this, solve for h. The h squareds cancel. Subtract h squared on both sides. Move this around. We're going to get p squared minus 100 on this side. Move this to the right side. 2ph. Now divide by 2p on both sides. 2p, 2p. These cancel. We're going to be left off with, now h is equal to p squared minus 100 divided by 2p here. So now we've solved for h in terms of the perimeter p. Well, yeah, that's a pretty interesting way of doing this. Yeah, so that's all for today. Hopefully you learned from this example here and how you can basically look outside the box when you look at the system of equations in here, and then when it's hard to solve directly, just look for familiar stuff and try to make it in the form of that. So yeah, just in this case here, the right sides, you could FOIL out an expression of a plus b squared to make it look like each other in two ways, and then you could basically, like what I did, just make them equal each other and solve for h. Well, that's all for today. Hopefully you learned from this problems plus example. Hopefully I'll do some more later on. And that's all for today, and stay tuned for another math easy solution.